Hey guys, it's Gigi going over written assignments 8, question number 7. And the question is asking you to find the area of an ellipse, meaning an oval thing. And that's the equation of that ellipse, the top part. And then the bottom part would be the negative of it, right? So now the area of an ellipse, if you can see that there's symmetry and there are 4 parts that are exactly the same. So that the area, we would say, will just equal to 4 multiplied by the integral from 0 to a. In this case, I am looking at vertical strips. And vertical strip would be dx. And then the height would be the function value. So that would be b over a multiplied by square root of a squared minus x squared dx. Okay, so that will simplify to be 4b over a, that's the constant, the integral from 0 to a of square root of a squared minus x squared dx. Now, what is it going to take? It is going to take a trig substitution. So let's go and take a look. So here is the right triangle. We have theta right here, and we're looking at a squared minus x squared. So a would have to be the hypotenuse, and I would say x would have to be the opposite, so that we have a sign substitution. So sine of theta is going to be x over a, or we would say x is going to be sine a sine theta. So dx is going to be a cosine theta, d theta is equal to dx. Okay, so when we do this substitution, we would say the area will equal to, and I'm going to go ahead and ignore the limit of integration so that I can go ahead and actually let's do the integration first. Okay, so we have the integral. I'm not going to even write the word area because I'm not doing area, I'm just doing the integral here. The integral of a squared minus x squared, this is square root of a squared minus x squared. So that is going to be cosine, right? So we're looking at adjacent over hypotenuse being cosine. So that would be a cosine of theta. And then dx is a cosine of theta d theta. So I really do have the 4b over a down here. So then a cancel with one of these a. I will just now have 4ab integral of cosine square of theta d theta. And cosine square, we know, is going to be 4ab integral of 1 plus cosine of 2 theta d theta over 2. Okay, so when we take the integral, we would have 1 over 2 theta. The 2 cancel with 4. We'll have 2ab theta plus the integral of cosine is sine of 2 theta divided by 2. There was already is the 2 on the denominator. That makes it 4. 4 cancel with that 4. So all I have is AB plus C. Okay, let's move to the next whiteboard here. I'm going to go ahead and copy that over. So everything is good except for we have sine of 2 theta, and here to reference we know theta, the angle theta, not 2 theta. So we have to change that and say that is 2ab theta plus sine of 2 theta is 2 sine cosine. So that would be 2ab sine of theta cosine of theta plus c. So if we were to go back and say what our area is going to be, I'm going to put x back in, 2ab, right? And we know that sine of theta is x over a, so theta is inverse sine of x over a. And then we are looking at 2ab and I don't know why I did that. I should just keep both of them have 2ab. We should keep the 2ab in the front just to be clean. And then plus sine is opposite over hypotenuse, x over a multiplied by cosine, which is adjacent over hypotenuse, square root of a squared minus x squared over a. And we are evaluating that from 0 to a. Okay, so now we just have to go and do that evaluation. I'm going to keep 2ab here up front when upper minus lower, right? So upper minus lower. That's not how I want to write that. I want to write parentheses, upper minus lower. Okay, so when x is a divided by a divided by a, I have 1. And inverse sine of 1 is going to be pi over 2. And then when x is a, I have a squared minus a squared. That's going to be 0. So that whole product right there is going to be 0. And then when x is 0, inverse sine of 0 is going to be 0. And then when x is 0, this part is 0, so that makes the whole product 0. So we have 0 right here. Good thing for a bunch of zeros, right? So really all we have is pi over 2 multiplied to 2ab. So the area of an ellipse, oh, that's not how you spell that, S-E. The area of an ellipse is, the 2 cancel with 2, you would have pi multiplied by AB, where A is the radius on the x like this. That's A, right? That's A right here. And B is that length right there. So if we know the 2 radii of the ellipse, then you will just have to multiply A times B times pi. That's really cool. Right now, you can actually find the area of an ellipse. Say like this. If you have an ellipse like this, say this right here is 2, and let's say this right here is 5. So the ellipse going like this. If you were to draw that picture like this, you're like, oh, hey, I know how to find the area of that shape now. The area of that shape is pi times A, which is 5, times B, which is 2. So the area is 10 pi. That's pretty awesome that we actually have just done that. We just now proved that the area of an ellipse is pi times A times B. Kind of like area of a circle. Area of a circle, as you know, is pi r squared, right? Let's think about that for just a second. What's the difference between an ellipse and a circle? You have two different radius. There's this one right here, that's called A, and there is this one right here, that is called B, right? So when you have a circle, when A and B are the same, then really you will have r squared, pi r squared, exactly the same as the circle. That's even cooler than cool, what we just did. That's pretty awesome. I'm pretty happy. And you can see I don't have my video on, but I'm actually smiling. Like, that made me happy. I hope you have just learned something new here.